first order linear differential equations. Okay, let's start with definition. What is a first order linear differential equation? It is a first order differential equation is linear if it can be written as y prime plus p of x y is equal to q of x, where p and q are continuous functions in some domain D. Okay, let's give one example. So, for example, dy over dx plus 5 over xy is equal to ln x. So this is linear. So when x is equal to 0 is linear. Also, so we have p of x is equal to 5 over x, q of x is equal to ln x. So since these two functions 5 over x and ln x are continuous on this interval 0 infinity. Okay, let's give another example. So let's say this is example 1. Second example, let's look at this one. X times y prime plus x plus 5 y is equal to x cubed. Again, it is given that x is equal to 0. So this is linear, but it is not in standard form. It is linear, but it is not in standard form. Let's look at the coefficient of y prime here. Here you see the coefficient of y prime. Here we take it 1. But in this example, we can easily arrange it to be 1 by dividing 1 over by dividing by x. Then by dividing the equation by x, we get y prime plus x over 5 over x, y is equal to x cubed over x, it is x squared. So we can divide by x because you see x is not equal to 0. So now this is linear in standard form. So we have a linear differential equation. Okay, and so px and qx are continuous. Also px and qx are continuous on this interval 0 infinity. Okay, I mean we can give as many examples as we want. Sine x y is equal to e to the power cosine x. So this is also a linear differential equation. Okay, what about this one? Y prime plus, let's say, x cubed y is equal to x squared or y squared. So as you see, this looks like linear, but this is not linear because here we don't have q of x, so it doesn't depend only on x because of this y squared term. So we don't there is no problem with p of x, but we cannot take this as q of x. So this is not linear. Okay. So, but we will only try. So today we will only try to solve this kind of differential equations, and they are very easy to solve. So how we will solve them? Okay, how to solve these differential equations. So let's say that we are given y prime plus pxy is equal to q of x. If p of x is equal to 0, then this term will cancel and we will only have y prime is equal to q of x, and we have a separable differential equation, and it is the easiest one. So we can separate the variables. We collect y terms onto the one side and x terms onto the other side, and we just integrate and find the solution. So if p of x is not equal to 0, then we will just rewrite the equation dy over dx is equal to q of x minus p of x y, and we just write the equation as some type like m dx plus n dy, and try to solve using exactness. So in this case, we have a very nice situation because we can easily find the integrating factor. The derivative of m, the coefficient of the dx with respect to y is just p of x, right? And n is equal to 1, so n is equal to 1 in this case, and its derivative with respect to x is equal to 0. So we can use this formula for the integrating factor. If we start with 1 over n, then we will continue with m. So what is n? N is 1. Del m over del y is p of x minus 0. So, and this depends only on x. You see, it is on p of x, only on x. Then the integrating factor factor mu is equal to, we know it is equal to e to the power p of x dx. Now just multiply with the integrating factor. Okay, now multiply the equation. Let's this one, y prime plus p of x y is equal to q of x. Multiply the equation with the integrating factor. Mu, and we find it e to the power p of x d of x. Okay, let's do that, and we will find something very nice. So mu y prime plus mu p of x y is equal to, don't forget to multiply the other part, mu q of x. Okay, what we find is e to the power, the integral plus e to the power, sorry about that, equal to mu times e to the power p of x dx q of x. If you can realize here, we have a derivative of a product actually. So we have a derivative of a product. So it is the derivative of this product actually, and it is equal to e to the power p of x dx times q of x. So recall the product rule. Okay, recall the product rule. What was it? When you want to take the derivative of a product, it is u v prime plus u prime v. We have exactly the same thing here. And okay, let me remind you how we take the derivative of e to the power ax. So it is a times e to the power ax. And here we have u is equal to, and here u is equal to e to the power p of x dx, and v is equal to y. Oops, it is too small. And v is equal to y here. So u times v prime, so u times y prime. Okay, u times y prime plus the derivative of u, the derivative of e to the power sum, the derivative of this part, the integral derivative of this integral is just p of x, right? P of x times v is equal to this product, and we can solve just y from here just by integrating. So to find y, integrate both sides. So we will just integrate this derivative e to the power p of x dx q of x, and this integral is just equal to the inside, right? So this is just equal to, oh, it is too small. Okay, I will write this here. And what is this integral? So we know that f prime of d of x is equal to f of x plus c. So when we take the derivative, the integral of the derivative, it is itself, right? So we have e to the power p of x dx y is equal to the integral so you shouldn't forget to take this integral also. Okay, I forgot to write integral here. Okay, now we will solve some problems and you will understand it better.